this is my first time at Monktoberfest. I want to say, first of all, this is amazing. There have been these talks on like life and death, and I developed my personal philosophy and solved 3 underlying physics problems along the way. And I'm a little bit intimidated because my talk is basically, I can tell you when my doggy goes pee-pee. So we're going to see what happens. This is Prometheus for Pets, and we're going to talk about data and animals. So the first thing you're probably wondering is not what are all the props. You're actually thinking, is this your dog? And the answer is no. A, I would never turn my dog into a Borg. And B, no, this is a drawing. Think before you ask questions. Come on. This is my dog. The closest to making him into a Borg that I've ever done is put my glasses on him, and I got a withering death stare as a result. By the way, I rehearsed this a couple of days ago at home, and when this slide came up, he growled the entire time. Just, so he does not like this picture. He did not like me sharing this. But he's not actually a Borg. So what am I going to talk about here? Well, what is this talk? It could be keeping tabs on your pet. It could be things like looking at water consumption or how long they're outdoors. But in actual fact, it's about having a fun project to get into IoT, Internet of Things technology, data analytics, things like that. I know when I'm trying to learn something or trying to play with new technology, it makes it a lot more interesting to me to have a solid problem to engage with, something real to do. And so I'm hoping to inspire a little bit of that for everybody here. I will say this is going to touch on hardware and software. And one of the weird things about being in an audience like this, or having an audience like this, is that probably everybody in here knows more about at least one of those topics than I do. But my experience has been that not everybody knows both. And like, I was a software guy for a long time. I went to school to get a computer science degree. I wrote code for decades. I never really grokked hardware. I never really understood it. So that's why it's kind of weird that 10 years ago I went and worked for an IoT company. And yeah, at that point I started to learn hardware, and it wasn't as scary as I thought it was. And I've gotten to the point now, 10 years later, where I can successfully, 9 times out of 10, pick up a soldering iron without burning myself. So I'm doing great. Disclaimer, first of all, I'm not a veterinarian. None of this is medical advice. Please, please, please do not try to make something at home your only way of keeping tabs on your pet's health. I hope nobody would do that. Your pet loves you. They want your attention. You should engage with them. Don't try to automate them away. But other than that, let's get going. So we're going to talk about hardware and software here. Like I said, I figure that not everybody in here is versed in both worlds. So everything that I talk through, I will give more detail about the time that we go to use it in the demos. So we're going to use some IoT dev boards based on the ESP32. If you don't know what that is, that's fine. We'll talk about it in a minute. We're going to just use some very cheap off-the-shelf sensors to get data into these things. We're going to use some cheap off-the-shelf devices to get data out. So think lights and sound, things like that. And of course a computer. So I'm going to run all of this on my laptop. This can run on a desktop. This can run on a Raspberry Pi. Everything that I'm going to show is very lightweight. It doesn't need a whole lot of power to run. And on the software front, everything here is open source. So we're going to look at Prometheus, which is kind of a database for keeping metrics. We're going to use MQTT, more on that later. And we're going to use Grafana, which is a visualization engine to look at the data. So I'm hoping that everybody in here can find one thing on this list that they haven't touched before, and you get to take something out of this. So I'm going to start with the hardware front. And these are microcontrollers. These are actually development boards with microcontrollers on them. Mad Dog held up a single board computer earlier. He also held up a microcontroller. These are the kind of things he was talking about. And the reason that I love these is that they are powerful and cheap. They're powerful for the size that they are. They're not powerful compared to like the processor in your computer or the processor in your phone. but they're actually not that bad. Like if one of these things were a desktop computer 40 years ago, it would blow everything out there away. These things, the ESP32, which is the chip I'm focusing on, has 2 processors. It runs at 240 megahertz. It can have up megabytes of storage, megabytes of RAM, and it has Wi-Fi and Bluetooth and a bunch of other things in it. Like, these things are insanely powerful compared to what we had everywhere running businesses 40 years ago. And on the flip side, they're super cheap. The quarter there is for scale. It's not because they only cost a quarter, but these development boards can run you $2 or $3. I think the most expensive one that I'm going to show in this demo was about $16. So you can get these things. You don't have to worry too much about playing with them. If you break one, okay, who cares? You can put it into a project. You can leave it there. Oh, and they're insanely low power as well. So you can use a USB battery like you would use from a phone charger to run one of these things for days, weeks, even months, depending on the workloads you're running on it. They're just super cool devices. I get excited. Software side, we're going to focus on Prometheus, MQTT, and Grafana. So Prometheus, we'll go into a lot more detail here in a minute. But it's basically just where we're going to store data that we collect from these devices. We want to capture data about what's going on in the environment. We need a place for that data to live. Prometheus is going to be that place. MQTT, I had to put on the slide because I can never remember, stands for Message Queuing Telemetry Transport. We'll talk a lot more about that later. Don't worry if you don't know this. We'll get into detail when it comes up. And Grafana is the visualization engine for all of this. It's a way of connecting to different data sources and databases, Prometheus, all kinds of APIs, and then giving you a set of tools to see all of the data in one place. And what are we going to do with these things? I'm going to build some toys. We'll build a pet door monitor. So we'll start nice and simple, just track how often your dog or your cat or your lizard goes in and out of the house, just so we can kind of look at trends in that data. Then we'll build a water monitor. We'll see how much your pet is drinking and how frequently. We'll build an alerting system. So we have data, what can we do with it? Well, we can say when something goes wrong. And finally, we'll take some of that data and perform analytics on it to see even cooler things that we can do as you add more and more data. So the title of this talk is Prometheus for Pets. I probably should talk about Prometheus at some point. So what is Prometheus? It's an open source project. And if you are anywhere in the cloud computing area, you've probably used it already. But if not, Prometheus is sort of the de facto metric storage database. So it's a time series database. Time series data is just anything with a timestamp and a number. So think like the weather report. You know, it's going to be a certain temperature in the morning, and it's going to go up and down in the afternoon and evening. That's time series data. Or stock market data. Your stock goes up, your stock goes down. It's all tracked over time. That's time series data. So Prometheus will store this data. It gives us a query engine to ask questions about the data. Hey, give me the data for last week, or tell me what the average was over time for this series of points. It does have a lightweight UI. It's got a web UI, which we'll look at briefly. To be perfectly honest, I think 90% of the time, if you're using Prometheus, you're probably doing it in Grafana. They go together like peanut butter and jelly. But you can use it on its own. And finally, Prometheus has a collection mechanism to get data from services or devices. It, by default, reaches out to devices or services and says, hey, give me your data. Just on a regular basis, it says, give me data, give me data, give me metrics. Prometheus, for some reason, calls this scraping. So if you hear me talk about scraping data or you see scraping in here, it's not some weird medical thing that I'm doing to my arm. It's just what Prometheus calls this. And I know this is absolutely unreadable. You don't need to read it, don't worry. I wanted to talk about one of the reasons that Prometheus has become so popular, has become this kind of de facto standard for metrics. And a lot of it is that it's incredibly easy to produce metrics in Prometheus format. So this is actually an excerpt of the Prometheus metrics from one of my systems at home, from a computer that I have running in my garage. And you can see, well, you can't read, but hopefully you can see, this is just a text file. It's plain ASCII text. When Prometheus requests metrics from this computer, what the computer sends back is really three things. It sends a metric name, so CPU utilization, for example. It sends a set of key value pairs that Prometheus calls labels, so CPU equals CPU 0, CPU equals CPU 1, CPU 2, and so on. And then finally, it sends a number. And it's always a number. It's never a text string or anything else. And it's always a 64-bit floating point number. So there's not a lot of options in producing Prometheus data, but it makes it very, very simple to add this to a program. So it's kind of caught on like wildfire because it's very easy to integrate with. All right, so let's actually build something. Sneak preview, it's this. This is just a cat flap that I ordered on the internet. And you can see I've cleverly Velcroed, sticky Velcroed on a microcontroller and a sensor. And we'll talk about those things right now. So the microcontroller is the brains here. This is the processor that is doing all the work. In this case, this is a board from a company called Adafruit. I'm not affiliated, but I do love their stuff. They make a lot of good documentation, and they have examples for everything. They make it really easy to get started. But this board is called the QT-Py. And the reason it's called QT-Py is because it runs Python natively. So if you are already a Python programmer, you can start writing things on this board today. If you're not, Python's very easy to get started with. It's a simple language to learn and use. And the real advantage of it here is that Python is interpreted. It runs, you work with Python in real time. You write a statement in Python and it executes immediately. So you can plug this board into your computer and you can start writing code without compiling, without any extra steps, and it'll just run on this device. So it's really cool for learning and experimenting. And then attached to that, we've got an accelerometer. And an accelerometer, I'm gonna need my hands. An accelerometer is just a sensor that measures acceleration. So why acceleration? Well, in this case, we want to know what orientation the device is sitting in. And it's measuring acceleration in 3 axes. So the cool thing is we can measure the acceleration from Earth's gravity using this. So if this thing is sitting like this, and we're measuring the force in this direction, it's 0. There's nothing pushing the device right now. But if I lift it up like this, now there's a 9.8 meter per second squared force pulling down on it, just gravity, right? I flip it the other way, it's got a negative 9.8 meter per second. My arm doesn't bend that way. But we can measure the force of gravity and use that to tell what orientation the device is in. And of course, we're going to use Prometheus to store the data. As I said before, Prometheus is going to scrape the data from the microcontroller, pull it back, and store it. Looking at the code, like I said, this is Python code, so it's very straightforward, easy to use. Even if you don't need to read this. I've published all this on GitHub. I'll give you folks a link at the end. But I harped earlier about Prometheus being so simple to build metrics for, in part so I could get away with what I've done in my code here, which is, it's Python, there are Prometheus libraries, I could have pulled a library in, but in this case, I'm literally just tracking how many times was this door flipped up and down. It's so simple, I don't need to pull in a big library. Instead, all I do is the first 3 lines up there are using Python's built-in web server. So start up a web server, connect it to Wi-Fi, listen for connections on port 8080. And then the rest of this is just every time somebody comes and asks for metrics, just send back a text file, just a plain text representation of that Prometheus format and append the values to it. So I'm just saying, hey, it opened, it opened, it opened, and I'm just spitting out plain text. So I can create a Prometheus instrumentation in like 6 or 7 lines of Python. It's really easy. The rest of the code on this device is just capturing the metrics. I'm going to loop forever. It says while true, so just go forever. Get the values from the accelerometer. If that value is greater than 4, then we're going to assume the door is open. Why 4? Again, we got 9.8 meters per second if it's 90 degrees out. We're going to say if it's, I don't know, halfway, 4 is a little less than halfway, then it's probably open. If it's 4 in the other direction, the negative direction, it's probably open this way. And otherwise, we're just going to assume that the door is closed. So that's it. We're going to run that forever and ever and ever. And then anytime Prometheus reaches out and wants that metric, it's going to pick it up. So everybody cross your fingers. The most nerve-wracking part of any live demo is the live demo. Right? It's my Yogi Berra moment for the day. Oh. Sorry, I've got to grab an adapter. USB-C and USB micro do not fit together. All right, I'm going to plug this thing in, turn on the power. All right, this is my nothing up my sleeve moment, not connected to my laptop. Now, I have Prometheus running locally on my laptop. Like I said, this is very, very lightweight. It doesn't take a lot of resources to run. So I'm just going to simulate some data. I'm going to go in and out of the door a couple of times as if I were my dog. All right, now I've got Prometheus set up to scrape this data every 5 seconds. So hopefully I have talked long enough that it has done a scrape. And if I just search for the door use, yeah, that's what I called it, door use counter total. Prometheus metric names tend to be very wordy. Yeah, you can see here, if you probably can't read it, but I've got one that says entries of 2, and one that says exits of 1. This is... Come on, it's not that great. We'll do more interesting things later, trust me. Prometheus will let you graph some of this too. Let's zoom out and look at just the last 1 minute. I'll flip it a couple of more times. And if I have waited long enough, I'll come back and refresh this, and we'll just see that it continues. Yeah, we've got a couple of more values. So it is good, go us, pat on the back. We've got some data, but we can do more. So let's leave the pet door for now, and let's build something more interesting. All right, another thing we can monitor with our pets is their water consumption, right? Water has weight. We know that we can measure weight with scales, so let's do that. In this case, I'm going to use a different microcontroller. I kind of did this on purpose. I've got several different vendors, several different microcontrollers, just to show that there is a variety of devices that you can use. You're not tied into one ecosystem. They're all compatible with each other. And in fact, I should have pointed out earlier, I did limit myself to only things that you don't have to solder. So all of the things that I'm showing, literally, they come with wires, you plug them in together. Not that soldering's that scary. So this device is from a company called M5. This is the M5 Stick C+, great name. And instead of Python, this is going to run something called Arduino. So Arduino is really sort of a wrapper around C and C++ to let you write C++ code and run it on these devices. Now, you might say, why would I want to write C++ when I could be writing Python? And there's a couple of reasons. One of which is, like I said before, Python is an interpreted language. There's something running on that board to look at your Python code and run it, and that adds overhead. So you have to have a fairly big board to run the Python code, and you're losing some of the clock cycles on that board to the interpreter. If I write it in C++, yeah, I do have to compile it, but then it's actually just running natively on the board. I can get away with a smaller, cheaper piece of hardware, or I can do more on that board. The other real reason to use Arduino, though, is it's been around for a long time and has a huge community behind it. And that community has developed a lot of libraries. So if you want to do anything, you want to use any sensor, any weird sensor that you can find, somebody has written an Arduino library for it. You want some weird output device, somebody has written an Arduino library for it. You want to do cruel things to trigonometry, someone has written an Arduino library for it. So it makes it really easy to go grab these things, plug them together, and just build what you want to focus on. Now, I'm going to connect this to a digital scale, and I'll talk more about the scale in just a moment. Let's move on to the rest of the architecture here. Again, we're going to capture this data in Prometheus. But this time I'm going to switch it up. Instead of having Prometheus scrape data from the device, I'm going to push data from the device to Prometheus. Again, it's mostly just to prove that I can do this in multiple different ways. People have strong opinions about whether pulling or pushing data is the right thing, and holy wars are fought over it. I'm not going to get into it. You can do what you want. And this time we'll add Grafana onto it to visualize the data. Now, finally, you get to know why I have my Lego bricks that have been sitting in my closet since the 1980s. It's because the M5 devices have the really cool property of having Lego connectors built onto the boards. And I was going to 3D print a stand for the scale, but then I realized I had Legos and I could just build it, and that was way more fun. So this is a picture of kind of the underside of the scale. The scale itself is sitting in between the weird basket on top and the red bricks on the bottom. It's just hard to pull apart and get back together on stage. So if we look at the code for this, again, this is C instead, or C++ instead of Python, but it's kind of got the same structure. There's a bunch of boilerplate that we do up front. Again, you don't need to be able to read any of this, but it's basically just setting things up. I've run this one time when the board starts, and it's like, initialize the board, connect the scale, turn on the LCD because there's a little LCD on the device, connect to Wi-Fi, things like that. So it's basically boilerplate. It's the sort of thing you're going to repeat in every project. But then we're going to loop over and over and over. And in this, basically it's the same idea. I'm going to get the value from the scale. I'm going to print it on the LCD, and I do a little bit of math here to say, like, okay, if it's less than a third full, then I'm going to print a message that says, hey, it's empty on the display, and if it's more than 2/3 full, I'm going to say it's full, but otherwise it's basically get the value. We're going to push that value to Prometheus, and then we're just going to wait 5 seconds and do it again. We don't need to check the dog's water literally every second. 5 seconds is way more than enough. So, if one demo is scary, yeah, thank you for the crossed fingers. If one demo is scary, 2 is terrifying. All right, I'm not going to bother putting the display in a way you can read it because it's too small for anyone to see anyway. But I've got a scale, I've got a water bowl on it, and of course, I have whatever it is that they use in paper towel commercials. I assume this is dog Gatorade, so we're going to give it to Ruggles. Okay, I've filled it up enough that hopefully you can see a little bit of the blue liquid. And what we're going to do this time is go to Grafana to look at this. So let me log in. Please don't try to guess my password. It is definitely admin. And what I'm going to do is I'm just going to quickly make a dashboard to visualize this. So we'll create a dashboard. I'm using Prometheus as my data source. I believe I called this weight. Yeah, weight in grams. And that's it. If I refresh this data, okay, good. Let's shrink this down because looking at the last 6 hours isn't going to tell us much. All right, this is the last 5 minutes. We've got some data here. Cool, we can do things with this. This is great. Maybe we add a little bit more water. And hopefully, I added it at just the wrong time. I'll have to stall for 5 more seconds. We should see that line bump up a little bit. So now we've got the basics of, we can see when the dog goes in and out. Thank you, thank you. We can see when the dog goes in and out, and we can see when the dog is drinking water. So the final part that we want to do is make use of this data, right? So this is where I'm going to bring in the final piece of software, MQTT. It's basically just a lightweight message transport system. So if I wanted to do something like have a digital scale that measures water, and I wanted to be able to, say, make a bright light or a sound play when the water bowl gets too empty, I need those things to talk to each other. right? And I could write a bunch of code on each of these devices that says, hey, go check to see if the alerting device is online. Yep, I'm online. Okay, great, I got a message for you. Cool, I received it. Okay, I'm doing something. Like, I can write all that code, but to be perfectly honest, it's a pain in the butt, and I don't want to do it. What MQTT does is handle all of that for me. It's a really lightweight service that just passes messages from a publisher, which is any system that sends a message, to a receiver, or excuse me, a subscriber, which is any system that receives a message. And I can have dozens or hundreds or thousands of publishers, dozens or hundreds of thousands of subscribers, and MQTT will deal with all of the connections, and I don't have to think about it. Now, how do I know as a subscriber if I'm getting the message I want? Every message has a topic, just basically like a title. Think of them kind of like nested folders. In this case, I'm just going to call them dog/alerts because I'm not that creative. So I'm going to build an alerting system with this. Again, we're going to start with a microcontroller. This one is called the M5 Atom Matrix because it has a matrix of LEDs, very clever. Also runs Arduino. And this time I'm just connecting it up to an audio device. And this audio device is, as I learned after I got it, it's just an MP3 player. Like, I literally put an SD card in there with a sound file on it, and the microcontroller can say, play, pause, next track, previous track, that sort of thing. Nice and easy. And then we're going to have Grafana and MQTT to send the data to that device. So I'll grab these and turn them on. Speaker works. Okay, my device is, I was trying to make something that indicated that it was connecting to Wi-Fi, but it didn't work well. Okay, so hard to see, but there's a little green smiley face. How does this work? Well, we've got MQTT, like I said, and so the two things that I really need are getting a message and doing something with it. So if I get a message, all I'm going to do is look at that topic and say, is this the dog alerts topic? If not, we just ignore it, leave it. If it is a dog alert, we're going to look at the content of that. Now, we're going to use Grafana to send an alert. Grafana by default sends big JSON packages. I could put a JSON parser on here and I could pull all the relevant data out and stuff, but I'm super lazy, so I literally just said, one of the fields in that JSON object is called status. If that field exists in there and you see the word firing, I'm going to assume it's an alert firing. If not, it's not firing. We're not getting an alert. That's it. So 5 lines of C to be able to do that. And then the board itself is, again, it's just going to run in an infinite loop. It's going to say, hey, do I have a message from MQTT? And then it's going to check that alerting status that the previous function would set. So if we are in an alert state, we are alerting, it's going to draw a sad face on the screen, and it's going to play the audio if it's not already playing. Otherwise, it's going to put a happy face on the screen and stop playing. So there's not a lot to this stuff, but you can start to see how it builds up and becomes cool as you connect them together, right? So, okay, everybody's tired of demos at this point. Me too. It's the last physical demo, I promise. All right, so I built this dashboard before. I hope I'm not leaking water. I don't know why it's going down slightly. May need to clean up on aisle 3. Let's create an alert rule on this data. Oh, no, I have to save my dashboard first. Yeah, it can just be new dashboard, that's fine. I usually give things descriptive names, but new alert rule. Okay, so we've already got this, this metric set up. We know we're tracking weight. Alert condition, okay, when it is below, let me see what it is now. It's currently 503 grams, so we'll pretend that, I don't know, 490 grams is when it's empty. Grafana by default stores everything in folders for organization, so we'll just call this dog alerts. I have to create this and call it dog alerts. One of the things that we want to do is shrink the window of how frequently this is going to be checked to as short as possible. Normally, you know, if you're tracking health of a system or something, you probably don't want to get alerts every 10 seconds. Like 5 minutes is probably plenty. I want this to happen quick. So we're just going to shrink everything down as fast as it can go. And the final part is I'm going to send this via MQTT. So I've pre-configured MQTT in Grafana so that it knows how to send a message, but that should be it. So let's look at our alerts. Actually, let me go back to the dashboard. What I'm going to do is that's not it. I am going to have a dog come in and drink some of this water. This is a dog. Everyone recognizes a dog, right? It's very thirsty. All right, we're now at 471, and this will evaluate every 10 seconds. So worst case, you have to listen to me, try to stall for 10 seconds.
Oof, I'm thirsty.
So there's my sad face.
Woof, I'm thirsty.
And that's my dog being sad. And if I come back and fill it up, again, we should see in 10 seconds.
I'm thirsty.
After you listen to the dog a few more times, it'll go back to the happy face. You can also see in here, Grafana, we can see when the alert was triggered. So we'll see when that was triggered, and we'll see when it was cleared. So again, we've got some cool things that we can do with this. Like, this could legitimately actually be useful as it is. But we want to do the data analytics parts. I'm going to have to rush through part of this. I think I'm definitely talking longer than I should. We can apply data analytics to make this more useful. So the one place I'll cheat and not run something locally is I am using Grafana Cloud, which is just a hosted service for Grafana, Prometheus, et cetera, because I wanted to simulate data for this for several weeks, and I didn't want to leave my laptop open for that long. So I vibe coded a Python script that just pretended to be a dog going in and out of that dog door, and what it does is it sleeps all night. It wakes up at some point in the morning, goes outside, stays outside for a while, comes back in, and so forth. So I've got 3 weeks or so of simulated data. And again, I can do simple things with this. I can say, like, yeah, I can just look at when the dog's going in and out and say, are there any interesting patterns here? There's a bunch of ways I could represent that data too. Some of it's more useful. Maybe I should probably expand this out to longer, but that's all right. Maybe it's more useful to see, how it's changing day over day. But it gets way more interesting when I start to add other data in here. So I could look at the door use versus temperature, for example. Is my dog going out more often or less often when it's cold outside? But the real power of this is once you amass a decent amount of data, you can start doing cool things like machine learning on this. So what I did was I took this 3 weeks of data, and I ran machine learning against it, just a Facebook profit algorithm, and said, basically learn what the patterns are that this simulated dog does. And of course, in proper conference fashion, I played with this 2 days ago and broke my demo data. So fortunately, I had a screenshot of what I built. So, nope, not share. Slideshow. So what this is, the orange line here is the actual data, the data that was recorded by the dog going in and out. And there's kind of a fuzzy blue area around it. That's what the machine learning algorithm predicts the data will be in. And you can see it does a pretty good job. Like when the dog is asleep, it says, I don't expect there to be any real change in this data. When the dog's awake, I do expect there to be change in this data. So on the training front, this matches up pretty well. But then what I did was I changed my simulation to say, actually, I want the dog to go in and out very, very frequently all of a sudden. And you can see when that happens, the orange line shoots way out of the predicted values. So again, I could set up an alert based on this, but that alert is probably much more meaningful than just, hey, you should check the dog's water, which you should be doing anyway. This might indicate that, all of a sudden my dog is going out to pee a whole lot more than is normal. And I might want to be aware of that, even if I'm not home to see it, to be able to take them to the vet and get checked out. It's also possible that there's just squirrels in the yard and the dog is going crazy. That's much more likely with my dog. But yeah, these kind of things, the data that you collect like this can start to become useful and start to show trends that can actually be actionable. And that's it. If anybody wants to look at the code or try these things out, it's up on my GitHub. It's pinned there. Happy to answer questions. And otherwise, I know I'm between everybody and beer. So thank you very much.